Hello everyone, welcome to the Civil Grade channel. Today I am going to discuss how to calculate quantity of cement, sand, aggregate, water in concrete. So first of all, let's calculate cement in concrete. So these are the data we required for calculating quantity of cement, sand, aggregate and water. First, let us suppose we are going to calculate the quantity of 1 meter cube of concrete. Okay, and this concrete is wet concrete and grade of concrete is M25. This comes from mixed design, and for the M25 concrete we have mixed ratio of 1:2. It means one part is cement, one part is sand and two part is aggregate. So we are going to calculate quantity of 1 meter cube concrete. Okay, that is weight volume. So as you know that cement, sand and aggregate are in dry state. So first of all we need to make this concrete to dry state by multiplying with dry coefficient. So here dry coefficient is 1.54, which is constant. Now to make volume of concrete, that we have taken 1 meter cube for now, but inside it may be 10 meter cube, 20 meter cube, 100 meter cube. So accordingly we can calculate cement, sand and aggregate quantity. Now to make dry volume of concrete, as I mentioned earlier, we need to multiply with this dry coefficient. This dry coefficient with weight volume of concrete. Weight volume we have taken for now 1 meter cube. Okay. Now dry volume of concrete is equal to 1.454 into weight concrete volume. Okay. Now 1.54, and in this weight concrete volume is 1 meter cube. So multiply 1.54 by 1, will get 1.54 meter cube. Next, let's take the sum of ratios. Now for M25 grade of concrete, we have 1:1:2. Now take sum of all these ratios. So it means 1 plus 1 plus 2. It is equal to 4. Now let's calculate cement quantity. Now for calculating cement quantity, we need this formula, like cement parts in the ratio, and then which is multiplied by dry concrete, and then density of cement and divided by sum of the ratio taken. Now first of all we need to know cement parts in the ratio. Okay, here we can see cement part. This is cement part, this is sand part, this is aggregate part. So first cement part is cement content is 1. Okay, so we are taking here cement content as 1. Now dry concrete is 1.54. We can see dry concrete is 1.54, and then this is the density of cement, 1440 kg per meter cube density of cement. And then sum of the ratio, is, see here, sum of the ratio is 4. So we'll divide this by 4. Okay, and then we'll get, after multiplying, we'll get 554.4 kg of cement. Okay, it means for the 1 meter cube concrete we need 554.4 kg of cement. Okay, and as you know that in one bag of cement there is 50 kg of cement. Okay, so we'll divide this 554.4 by 50 kg, so that we'll get cement in bag quantity. Okay, after dividing we'll get it to 11.08. Okay, so 11 bag of cement required. means for 1 meter cube of concrete we require 11 bags of cement. Let's move ahead and calculate the quantity of sand. Now, in case of sand, we need sand parts in the ratio, that is sand content into dry concrete by sum of the ratio taken. Okay, now here sand parts in the ratio, let's go back, is 1. See, this is 1. Okay, so we'll take 1 and we know dry concrete is 1.54 and sum of ratio taken is 1 is to 1 is to 2, means total sum is 4. Now this became, after calculating we'll get volume of sand. Volume of sand is 0.385 meter cube. Okay, so if inside or somewhere this meter cube may be converted into cubic feet, so in that case we need to multiply this meter cube, this volume of sand, with 35.31 in order to get to cubic feet, because in some location they require cubic feet to calculate. So in that case we need to multiply of 10 volume of sand which is in meter cube with 35.31 so that we can get it into cubic feet. Okay, so now we got volume of sand in cubic meter and cubic feet also. Okay, now let's calculate this sand weight. Okay, so weight of sand is equal to volume of sand into density of sand. Now we know that volume of sand we calculated earlier here 0.385. Okay, and then density of sand, see density of sand is 1740 kg per meter cube. Okay, once you multiply with this volume and density we'll get weight of sand in kg. Okay, see this kg 669.9 kg. Okay, now let's convert this kg into metric ton, because in some location you will require to calculate sand in metric ton also. Okay, so in that case we'll divide this kg with 1000, then we'll be getting a metric ton. Okay, so in this case we got 0.669 metric ton, and after rounding off we can get 0.67 metric ton. So we can say for 1 meter cube of concrete we require 0.67 metric ton of sand. Okay, and or we can this is by weight. Okay, and in volume if you calculate the sand quantity it will be 0.385 meter cube or 13.6 cubic feet. Okay, now let's move ahead to calculate aggregate. Now we are going to calculate quantity of aggregate that is required for 1 meter cube of concrete. Now here also we'll take aggregate quantity is equal to aggregate parts in the ratio, that is aggregate content in the ratio into dry concrete by sum of ratios taken. Okay, then we know that for M25, let me show you. For M25 aggregate content is 2. So and this M25 and mix ratio has 1 is to 1 is to 2, means cement, sand and aggregate. Okay, so we'll get 2 parts of aggregate in this ratio. Okay, then aggregate part will be 2. Here we multiply by 2 and dry concrete is 1.54 divided by 4. 4 is 1 is to 1 is to 2. This is sum of the ratio. Okay, now first we need to calculate volume of aggregate. Okay, we got, after multiplying this we got 0.77 meter cube. So this is volume of aggregate that we require in cubic meter. Okay, now if we need to calculate in cubic feet, because it required in some locations, so we need to multiply this cubic meter by 35.31, so we'll be getting 27.18 cubic feet. Okay, so this is volume of aggregate in cubic meter and cubic feet. Now let's calculate weight of aggregate. So we know that weight is equal to volume into density. So we know that density of aggregate is varies from 1480 to 2100 kg per meter cube. So in this we can take value that falls in between 1480 to 2100 in order to calculate weight of aggregate. So I have taken 1550 kg per meter cube density of aggregate that falls in between 1480 to 2100. Okay, now let's multiply this volume, okay, with this density. We'll get in kg. Okay, now we'll get weight of aggregate in kg. We got after multiplying 1193.5 kg. Now we need to we need this quantity of aggregate in metric ton. Okay, so we got result in kg, and we'll divide this kg result by 1000 in order to obtain the result in metric ton. So after dividing we'll get 1.193 metric ton, that is nearly about 1.2 metric ton. That means 1200 kg aggregate is required for 1 meter cube of concrete. And in the same way you can calculate when volume of concrete is 10, 20, 30, process is same, just change the value of 1 meter cube to 10 meter cube if you want to calculate for 10 meter cube, and rest all formulas and everything are same. Now we are going to calculate water that is required for 1 meter cube of cement, sorry, concrete. We have here water cement ratio 0.5. This comes from mixed design. Okay, mixed design 0.5, 0.45, and 0.3. So this comes from mixed design. Now for water, calculating of water, for 1 meter cube of concrete, we need water cement ratio, number of bag of cement that we calculated for this mixed design, M25, into weight of 1 bag of cement. Now in this case we have 1 water cement ratio 0.5, 0.5 number of bag of cement. Okay, see number of bag of cement that we calculated earlier. See 11 bag of cement. Okay, then weight of 1 bag of cement, because we want in kg, so weight of 1 bag of cement is equal to 50 kg. Okay, so 50 kg is here. Now after calculation multiplying this quantity we'll get 275 kg. Okay, now supposing 1 kg of water is equal to 1 liter of water, so this comes 275 liter of water in 1 meter cube of concrete. So in the similar fashion you can calculate 10 meter cube of concrete, 100 meter cube of concrete, and you will get quantity of cement, sand, aggregate, and water for different cubic meter of concrete. Thank you. Hello everyone, welcome to the Civil Grade channel. Today I am going to discuss about how to calculate quantity of cement, sand, aggregate, water in concrete. So let's begin. These are the data we required for calculating 1 meter cube of concrete quantity. So first of all, suppose we have 1 meter cube of concrete. Okay, and in this case we have taken grade of concrete M25. So according to mixed design for M25 concrete, mix ratio is 1:1:2, where one part is cement, sand, aggregate. One part is cement, one part is sand, and two part is aggregate. Now we have volume of concrete 1 meter cube, which is weight volume, but we need to calculate dry volume of concrete because cement, sand and aggregate are in dry state. So in order to calculate dry volume of concrete, we need to multiply weight weight volume of concrete with dry coefficient. So dry coefficient is 1.54. Okay. Now dry volume of concrete will be 1.54 into weight volume of concrete. So in this case, weight volume of concrete is 1 meter cube. Okay, it may be 10 meter cube, 20 meter cube, depending upon quantity we are going to calculate. But in this case, we have taken only 1 meter cube. Okay, inside maybe 10 meter cube, 100 meter cube, and accordingly we will be calculating quantity of cement, sand and aggregate. Okay, so in this case there is, I have taken only 1 meter cube, so we'll multiply 1.54 into 1, we'll get 1.54 meter cube of dry volume of concrete. Now let's take some of the ratios. Ratio means mix ratio, 1:1:2. This is the ratio of M25, comes from mixed design. Okay, so it will be 1 plus 1 plus 2 is equal to 4. Now let's calculate quantity of cement for 1 meter cube of this 1 meter cube of concrete. Now cement quantity calculation. For calculation of cement quantity, we need cement parts that is included in the ratio, which is 1, and then dry concrete that we calculated, and sum of the ratio taken into density of cement. See cement parts in the ratio here. Cement parts is 1. Okay, so 1 and 1.54. 1.54 is dry concrete. Here dry concrete is 1.54. Okay, then sum of the ratio taken, 1:1:2 means 1 plus 1 plus 2 will be getting 4. Now density of cement, we know that density of cement is 1440 kg per meter cube. So after calculating this, we'll get 554.4 kg. Okay, so for 1 meter cube of concrete we need 554.4 kg of cement. Now let's convert this kg into bags, because in market bags are available for cement, and in one bag there are 50 kg of cement. So we'll divide this kg in order to get bags of cement. We'll divide this kg by 50, which will produce 11.08. Okay, so rounding off we can get 11 bags of cement. So for calculating for 1 meter cube of concrete we need 11 bags of cement. Now let's move and calculate the quantity of sand. Okay, in case of sand, we need sand parts in the ratio, which is 1, because we have ratio of 1:1:2. Okay, 1 is cement, 1 is sand and 2 is aggregate. So sand parts in the ratio is 1, dry concrete is 1.54, and sum of the ratio taken is 4. 1 is to 1 is to 2 means 1 plus 1 plus 2 is equal to 4. So in this case, after calculating, we'll get value of 0.385 meter cube. So volume of sand will be 0.385. This is the quantity in volume of sand for 1 meter cube of concrete. Now in some place we need to calculate volume of sand in cubic feet. So in this case, we'll multiply this obtained value in meter cube with 35.31 so that we can get 13.6 cubic feet. Okay, in order to convert this meter cube into cubic feet, we'll multiply volume in cubic meter, okay, with 35.31 to get cubic feet. Okay, so this is the quantity of sand in meter cube. Now let's calculate quantity of sand in kg. So kg means weight of sand is equal to volume into density. Now volume of this sand is 0.385, okay, and density of sand is 1714 kg per meter cube. Okay, now after multiplying this we'll get 669.9 kg. Okay, now 669.9 kg is divided by 1000, means in order to calculate this, in order to convert this kg into metric ton, because in some location sand is calculated in metric ton, so in that case we have to divide this kg by 1000 in order to get result in metric ton. So we'll get 0.669 metric ton, and we can say it 0.67 metric ton. So for 1 meter cube of concrete we require 0.67 metric ton of sand, or we can say we require 0.385 meter cube of sand, meter cube volume of sand, or we can say 13.6 cubic feet sand is required for 1 meter cube of concrete. Now let's move and calculate quantity of aggregate that is required. So in case of aggregate also, aggregate is equal to aggregate parts in the ratio and then dry concrete divided by sum of the ratio taken. We know aggregate part is 2, we have ratio 1:1:2 for M25. So in this case aggregate content is 2. Here aggregate content is 2, and then this is dry concrete and this is ratio. So after calculating this we'll get volume of aggregate in meter cube. Okay, this is 0.77 cubic meter. Now in some place, as I mentioned earlier, some place they calculate aggregate volume in cubic feet. So in that case we need to multiply this 0.77 by 35.31, which result 27.18 cubic feet. Okay, so for the 1 meter cube of concreting we required 0.77 meter cube of aggregate, or 27.18 cubic feet of aggregate. Now let's convert this aggregate volume of aggregate into weight of aggregate. Okay, in that case we have formula weight is equal to volume into density. Okay, so in case of aggregate, density of aggregate is 1418 to 2100. So this falls between 1480 to 2100 kg per meter cube. In this case we have taken one value that falls in between those value, 1550. Okay, this is in between this both value. Okay, then 0.7, this is volume, this is density. Now we'll get result 1193.5 kg. Now if we need to convert this kg into metric ton, then we need to divide this kg by 1000 will get 1190 1.193 metric ton, or we can say 1.2 metric ton. So in order to calculate 1 meter cube of concrete, we required 1.2 metric ton of aggregate. Now let's move and calculate how much water content is required for 1 meter cube of concreting. Okay, in this case water cement ratio is 0.5. It may be 0.5, 0.55, 0.45, depends upon mixed design, but in this case I have taken 0.5. And for water we required water cement ratio, which is given here. Now the formula for calculating the quantity of water is water cement ratio into number of bag of cement into weight of bag of cement. So this number of bag of cement is what we have calculated earlier. Let me show you. So this one, 11 bags of cement. Okay, so here will be 11 bag of cement and weight of cement. Now we have water cement ratio 0.5 and cement we calculated 11, and in one bag we have 50 kg. Okay, so weight of one bag of cement is 50 kg. So after calculating this we'll get 275 kg of water. Now suppose 1 kg of water is equal to 1 liter of water. So ultimately we'll be getting 275 liter. Okay. Then for 1 meter cube of concreting we require 275 liter of water. Okay. In the similar way we have calculated here 1 meter cube of concreting quantity required for 1 meter cube of concrete. We can in the similar way we can calculate cement, sand and aggregate required for 100 meter cube of concreting and so on. Thank you.